waves and their properties, right? So the waves, waves have certain properties in them, where we call the maximum voltage or the peak of a wave is known as the uh, amplitude of the wave, and the length between two consecutive points in the wave is known as a wavelength. And then the frequency is defined using the wavelength, right? So we use C equals F lambda to find out the frequency of a certain wave once we know the wavelength of the wave, right? So likewise, the basic understanding about the wave we already know, right? And then in here, I'm talking about the polarization of electromagnetic waves, right? So the polarization means like how the electric field is behaving once it is propagating through the space, right? So if the electric field is maintaining a constant direction, we call that a linear polarization. But if the magnitude or the electric field is changing its direction according to a circle, right? If it is following a circle, once it is propagating in the space, we call that that electromagnetic wave is having a circular polarization. And then if it is having an elliptical propagation, right, that electric field is following an ellipse when it's propagating, we call that elliptical polarization. Okay, so as I said before in the previous class, we are basically talking about microwave region where we are, where we are talking about basically the gigahertz range, right? So in here, I think I need to change this. However, in the the common the definition for microwaves is between 300 megahertz up to 300 gigahertz. However, that is the common common definition for microwaves. However, in the engineering disciplines, we will be talking about ranges going from 1 gigahertz up to 300 gigahertz for the microwave engineering. And then we'll be talking about radar, microwave ovens. We will not be talking about microwave ovens in specifically, but we'll be talking about the communication aspect of microwaves, which are basically focused on radar systems, the transmission, I mean the circuit boards, a PCB circuit, microwave communications using transmission lines, right? And using microstrip lines and strip lines. Likewise, right? There are certain like transmission lines that we are defining for microwave communications in PCB circuits, which are used not only in the computers or any other devices, but also in our phones. So we find it widely in every device that we are using. So it's very important to know these circuits and how to design them. Okay, and then we are talking about satellite communication in these classes. So I think I have talked about the satellite communication a little bit in the previous class. And you know that satellite communication requires a higher frequency above in here we are saying space wave propagation, which is talking about the satellite communications and the direct line-to-line communications, point-to-point communications, which function with a frequency above 40 megahertz. So in that range, actually, satellite communications also happen, and therefore satellite communication will be like a topic in this module once we have finished with the basic designs of the microwave circuits. So I won't be going to explain the basics of the other types of waves. However, like I think it is better for us to know such concepts about electromagnetic waves in general, and how they are used, and what is the method of propagating them from one point to another, and so on. So as of now, I think I need to cover um, some content. So therefore, I won't be able to like go into uh, deep level in these ideas. However, I will just mention that the satellite communication, as I said, happens in very high frequencies, and it's very essential, and it's very important to understand what parameters that define the satellite communications, right? So like communication can happen in the like line of sight direction with parallelly to the ground, right? We call that ground waves. So it can happen along the ground waves, or it can happen in the sky wave as well. So once we have the sky wave propagation, it happens mainly because of some phenomena that is there in the atmosphere, right? So once we are trying to send some signal uh, in a certain direction towards the sky, right? The waves which hit the dense layers of the atmosphere, we call that the ionosphere, right? Um, those waves return back to the land, right? So the ionosphere is a layer in the atmosphere which get ionized during the daytime, and the ions in those layers are forming like a dense, like a thick layer that prevents the waves going through the space into the outer space. So because of that, the waves that the electromagnetic waves we are generating from the ground is not going to penetrate through those layers, and they're not going to go to the space. However, we are using this incident to send our waves from one country to another, right? So we can use these sky waves to send our signal from, for example, from Sri Lanka to India. Right? When we want to send like a signal in a like a considerably long range, right? Uh, I mean, from one country to another country, which are close to each other, we can use this skywave concept. We can calculate in the frequency and the angle in which we need to send the wave, and once we have those correctly computed, we can transmit the wave in such a way that we can send the wave to a certain location that we decide in the receiver end, right? So if the receiver is in India, right, if that person is in a certain state in India, and if we want to send the wave reliably to that location, we need to first calculate what is the angle in which I need to send this data such that my wave is going to reflect in that correct position in the ionosphere and then reach the receiver at the end, right? So this is something that we are seeing under wave propagation. So there are three types of waves. We call this ground waves, sky waves, and space waves. So when we talk about microwave communications, we are talking mainly about the ground waves and the space waves, right? So in the ground wave, when we are doing gigahertz range communications, we call that microwave communications, right? Line of sight gigahertz communications are known as microwave communications. And then when we talk about the space waves, in there also, because we are using gigahertz range frequency signals, and we are sending that into the outer space, and we are sending it in a certain angle which is above the minimum like critical angle defined for the the sky waves, then we can send our signal into the satellite, right? So that communication is also falling under microwave communications, right? In here, I'm talking about what are the factors that affect the quality of the wave propagated and the range of the communication, right? So when we are talking about the ground communication, right? Ground communication, I'm specifically talking about the line of sight communications, which are important for microwave engineering. So such line of sight communications are actually targeted to achieve short range communications, and therefore we are talking about like short distances, and in that as well we have some challenges in sending our data, where we need to consider about the interference from the environment, right? The environmental conditions like the conductivity, permittivity of the materials can make the signal to fade and attenuate and get lost after some distance, right? So the space waves, we are talking about, thirdly, the space waves, where we are talking about frequencies above the 40 megahertz, and such waves will be reaching for up to a wide range and above 1,000 nautical miles, we call. So nautical miles means the miles used by the Navy. So that above 1,000 nautical miles, I think a nautical mile is above a mile, more than a mile, a standard mile. So up to that, more than that range, we can do the satellite communication. So the satellite communication also has some challenges that are affecting the communication. So such challenges are like the signals are getting affected by the atmospheric absorption, right? And it can cause the signals to get attenuated, right? Okay, so if you have questions about today's class, you can ask. So I have talked mostly about the wave propagation and how those waves are applied in, I have talked about how those waves are generated, and I have explained about the Maxwell's equations and how we can, what are the properties of electromagnetic waves and how we can use those waves for ground waves communications and satellite communications, right? So those are basic things that I would like to cover in today's class. Also, if I have the time, I don't know whether I will be able to complete this, but I will also talk about the uniform plane waves in the upcoming lectures, where I will be talking about the properties of uniform plane waves, and then the characteristic intrinsic impedance of the medium through which this electromagnetic waves are propagating, and how to find the direction of a wave propagating. So those will be discussed, I think, in the upcoming lecture. So if you have any questions, you can ask. Put in the WhatsApp group. I hope you know about the WhatsApp group, right? So we have a WhatsApp group where we'll be talking about any concerns that you have about this course, right? So you can ask any questions you have. So we'll be resolving any issues that we have. And apart from that, I want to ask you, do you have any suitable time slot to do the interactive session class? I suppose that I asked you to find a time slot, but I don't know whether you were able to find a time slot to do the interactive class. So if you want to if you want to change the time slot, I would like to invite you to suggest me a time slot that that is preferable for all the students who are attending this class. So I think some 2 batches are coming to this class. So if you are if you are selecting a time slot, you need to select a time slot that is suitable for both the classes, both the batches, right? And for this course, we'll be talking mostly about the application side of the microwaves. And during our lab classes, we will be doing practicals on how we can measure the certain parameters of waves that we are generating, uh, and how we can measure the performance of the system in terms of the loss of the system. I mean, the energy with related to energy consumption as well we can take, because I think return loss and parameters like VSWR and S11, we can define the performance of a microwave system. And we can say that the propagation is really good and the performance is really good. So we are using certain apparatus like vector network analyzers in the lab to measure the performance of the wave that is propagated. So apart from that, we have some MATLAB simulations that we'll be doing as the labs. And then for the assignments, I will be giving some, activities. And I'm hoping to give such activities during the interactive class. And also I will be I'm hoping to give some quizzes during the interactive class, right? Because I think in the online class, I don't have the ability to separate a time for the quizzes. So in the interactive class, I'm hoping to give the quizzes. So if you're hoping to do the quizzes, you have to attend the physical lectures. So in that case, I hope that you can come to a conclusion with the time of the lecture on Monday. And if you want to change it, you can request to me, and then I will send that request to the my heads, and then I will ask them to change the time slot. Right. So maybe right. So apart from that, if you have any questions about the course, you can ask, as I said before. And also, I just want to tell you, just because there are some mathematics in this course doesn't mean that we are going to be evaluating the mathematical knowledge of your understanding only in this course, right? So we have we are focusing mostly about the application side of this microwave engineering. And the first 3 classes are basically about understanding the parameters of the waves that are propagated, and just understanding the parameters. And then we are going to do some designs in the softwares like HFSS, where we'll be seeing the performance of the designs, right? So it's our main focus is to finally design a good microwave circuit, right? We are talking about both active and passive circuits. So we'll be designing those things in HFSS, which is required if you are going to be a telecommunication or antenna engineer, RF engineer. So I'll be ending the class now. So thank you so much for attending the class today. I'll be